Well, this last section of this business statistics course is correlation and a specific type of regression called simple linear regression. These are the starting points where we start talking about quantifying, measuring relationships. And regression is, in my mind, the most important thing that you can learn. It is the pursuit of truth. We always want to know what causes something and how to quantify the relationship, that if I control this, if I modify this, what is the impact of that? And the starting point of that is regression, correlation and regression. Correlation can be measured with a statistic called the Pearson correlation coefficient. And it is a number that is anywhere from -1 to 1. If it's at the extreme, if it's at either -1 or 1, that's a strong relationship. If the correlation coefficient is equal to 0, there's no relationship. If it's minus, that means a negative relationship, and all that means is that as one goes up, the other one goes down. Positive means if one goes up, the other one goes up. We will correlate, we will develop correlations for all kinds of data as the starting point of looking for relationships. You may have heard nowadays when they talk about data mining. That's what data mining is. They're starting to look for statistics that say it looks like when people buy Coca-Cola, they buy potato chips, and looking for patterns in data. Now, just because there's an indicator does not mean that one causes the other, but it's at the minimum that has to exist. We want to first, our starting point is to say, hey, it looks like something is related, and then we can pursue saying that one causes the other. But you can't prove one causes the other unless there is some relationship has to exist. So correlation is the starting point, and then as we move more into cause and effect and we start developing theories, and it looks like, and again, theory is something where you look in the literature, you talk to experts, there has to be some type of temporal relationship, and all I mean by that is that one, if you're going to say something causes something else, the cause has to happen before the effect. Otherwise, it couldn't happen, even if there is a strong relationship. So correlation, in Excel, we can quantify that, or we can use Excel to capture these numbers for us. So we're not going to calculate these by hand. They can get pretty complicated. Correlation statistics are fairly detailed and take a lot of algebra, but we can use Excel to take advantage of that. So we're going to use this function, this CORREL, and grab 2 data points to calculate a correlation. And then we'll have one more video to go over regression. But let's do a correlation example. And I've got the data set that we have in the data file I provided you is the 1976 NFL football data. And what we want to do is look for, is there a relationship between our offensive statistics and defensive statistics. So if I have a team, and my team, and they have a good running game, does that mean they're going to have a good passing game? Let's look for a relationship there. And then also, if I got a defense that's good at stopping the run, is it also good at stopping the pass? I want to know if they're related or not, or there is no relationship. So let's study that. So here's the data, and this is the 1976 data. So again, that's the Washington Redskins, and these are my offensive stats. So this is how well my running backs ran. This is how well my quarterbacks and receivers threw the ball, caught the ball. So these are my offensive stats. And these are my defensive stats. So this is how well I stopped the run, and this is how well that I would stop the pass. So I want to see if this data, if this is related to this, and I also want to know if this is related to this. Whoops. So let's do that first. Here's the offensive stats. So we're going to calculate R. So there's the formula, CORREL, and I'm going to grab this data, and the order doesn't make any difference because the correlation of one, since we're not worried about cause and effect, the order does not make any difference. So I grabbed column C and then column D. I could just have easily grabbed D before C. It does not make any difference. And let's look at this. Well, we got a number, and again, it's between -1 and 1. And the first thing to notice, it's closer to 0 than anything else. It's not close to 1. It's closer to -1 than 1, but it's closer to 0. So I would start out without doing any stats. We're not going to worry about statistical tests, but I'm going to say because it's so close to 0 on a scale of -1 to 1, is that there is no relationship. So I'm not going to pursue any cause and effect because there's no reason to. They're not related. It looks, just because I have a team that can run the ball well does not mean one thing or the other about a team. It doesn't mean that having a good running team means that I have a bad throwing team. It just means they're not related. Knowing one gives me no information about the other. That's what no relationship means. Well, what about the defense? Let's calculate our R there, our correlation coefficient. And I'm going to grab my defense against the rush against my defense against the pass. Now that's very different. Look at that. That's very different. This number has started to move away from 0 and closer to 1. And I will tell you that it's hard to know. It is hard to know when we've reached a level where it's significant or where it starts becoming a stronger relationship, because in some situations, depending on what we're studying, this would be a significant R, and in some other things it may not be. It really depends on what you're studying, and that's a hard one. But at least relative to this one, there is much more of a relationship. So it looks like if I put together a defense that can stop the run, it will have some effect of stopping the pass. There is a stronger positive relationship. A good defense against the run seems to be have some relationship, positive relationship, that I'll have a good defense against the pass. And if it was really close to 1, that means that knowing one tells me everything about the other. If it was -1, then it would say that a team that stops the run is lousy against the pass. But that's not what we have. It looks like there's a positive between the two. And we can continue and do all of these different correlations. The correlation is always a bivariate statistic. It only gives you a number comparing two variables. But you can calculate it for all different combinations if you want. Okay, that's a good starting point for correlation. Thanks.